Hi there, welcome back. Welcome to our second video lesson together and welcome to my office featuring my noisy colleagues. Now, today I would like to discuss with you two important quantities related to credit risk. That is to say, the expected loss and the unexpected loss. As you can imagine, as you know, these two quantities are strictly related. But as we will see when introducing the different models to credit risk, we will handle these two quantities, the expected loss and the unexpected loss, in a different way. So let's start. The expected loss is what we expect to lose in case of default of a counterparty, simply the expected value of the future loss distribution for that counterparty. The computation of the expected loss for a given counterparty requires the knowledge of three different quantities: the exposure at default, the probability of default, and the loss given default. We will consider the probability of default starting from next week, week 2, where we will start modeling credit risk and actually computing the probability of default of our counterparties. The loss given default, on the contrary, is the topic of the next video lesson in this week. So I just refer you to that video lesson. Here, in the next minutes, I would like to say something more about the exposure at default, which is the third component that we need to compute the expected loss. First of all, notice that in principle, the exposure at default is not a deterministic quantity, but a random variable representing the current exposure plus its possible variation from now to the date of the possible default. Its variability depends on the type of facility under scrutiny. Naturally, there are situations in which the EAD is deterministic. For example, in most bonds or loans, where exposure is not random, but follows a predetermined repayment plan for both capital and interests. When exposure at default is stochastic, we can experience what goes under the name of exposure risk, that is, the risk that the actual exposure is larger than the amount we originally expected. Interestingly, differently from default risk and recovery risk, this risk is rarely really taken into account in modeling. Can you think of a situation, an example of exposure risk? Okay, I will do it. Assume that a company is granted a loan and that this company may vary within certain limits the size of this loan. Empirical evidence shows that companies in financial difficulties tend to use their loans up to their maximum. This makes the exposure at default increase, close to default. The estimation of EAD typically requires the measurement of three quantities: the drawn portion, the undrawn portion, and the credit conversion factor. This last quantity accounts for the proportion of undrawn portion that could be used close to default. Empirical studies show that CCF is typically between 40% and 75%. On screen, you can see a simple example of computation of the exposure at default for a $1 million credit line. Notice that including the undrawn portion leads us to estimate a greater expected loss and a higher price for the loan. No need to say that, in order to be competitive on the market, this increase should not be entirely transferred to the spread applied to the drawn portion. Okay, so that was the expected loss. Now I would like to tell you something about the unexpected loss. I will be quite general for the moment. We will see unexpected loss in its generality because we will be back quite soon when we consider the different approaches to credit risk, the different model, with the details about the computation of the unexpected loss, which is the real thing when we consider credit risk. Don't forget it. The unexpected loss is the variability of the possible loss around its expected value, the expected loss. When we consider a diversified portfolio of exposures, the expected loss of the portfolio is the sum of the expected losses on the single exposures. Why? Because the expected value in mathematical terms is a linear operator. The expected value of x plus y is equal to the expected value of x plus the expected value of y, and so on. The portfolio unexpected loss, on the contrary, is generally lower than the sum of the unexpected losses. Again, why? Because, as we will see, the variability represented by the unexpected loss is essentially measured in terms of standard deviations, and we know that standard deviation is a subadditive measure of risk. If you need to refresh these concepts, just check the extra materials of this week. Summarizing, the expected loss of a portfolio cannot be reduced by diversifying the portfolio. On the contrary, the unexpected loss can be reduced with suitable portfolio strategies, and this is why diversification can actually reduce credit risk. As already said, we will see the details in due time. So, okay, see you in the next video lesson. Thank you.